Hello, welcome to this video. This video is for IXL 8.W.15. It is titled Find the Number of Solutions. In this activity, and the 3-character code, can't forget that, right? The 3-character code is X-ray delta echo. In this activity, we are going to find out how many solutions that an equation has. It might have no solution. We can find out that there's no solution for it. It may have only one solution, which is what we've been finding mostly throughout what we've been doing so far. We've been finding x equals 5, or m equals 12, or z equals negative 21. Where we have just one solution. Or it could have an infinite number of solutions. Just an endless number of possibilities for solutions. So we'll go ahead and we'll start working through this, and as we hit each one, we'll kind of discuss what each of them are. So the best way to handle this, in my opinion, is to go ahead and start solving the problem. So let's go ahead and start working this problem out here. And let's do it up over here on the side. So if I have negative 10z equals negative 9z and minus 2. So, and let's cross our z's, I guess, so we know that they're z's and not 2's. Let's go ahead and add 10z to each side. So plus 10z, and over here plus 10z. And yeah, we'll go ahead. I'm tempted to go ahead and add the 2 to each side to send the 2 over to the other side. But at any rate, the 10z's will cancel each other out and give me 0. And then I have negative 9 plus 10. That's going to give me a positive 1. 1 what? 1z. Minus 2. So now let's go ahead and add 2 to each side, plus 2, and those cancel each other out, and I end up with z on the right and positive 2 on the left. So I just get, maybe I ought to loop that, make that look like a 2. There we go. So z equals 2. Z only has one solution. I come up with, just like we've been doing on so many of our other problems so far, is we end up with a variable that equals a number, and it just equals one number. So in this case, there's just one solution. On the next one, we have, work it out here over to the side, negative 4q equals negative 10 minus 4q. Now this seems kind of odd because I have negative 4q on both sides, but I also have a negative 10 on one side that I don't have on the other. So something seems a little awkward here. If we go ahead and say, well, let's go ahead and head down that road, try to solve it. So let's go ahead and add 4q to each side. And so I do plus 4q on each side. These cancel, those cancel each other. So I end up with 0 over here and negative 10 over there. And it's like the variables just disappeared. I end up with some statement that is a false statement. These two are not equal to one another. And if this happens, this means that there is no solution. There's no number that you can plug in there. And if we go all the way back to the beginning and we look at the fact that whatever q is, these two values right here, these two terms, negative 4q and negative 4q, are going to be equal to one another. So think of this as a scale, right? Balanced out on a scale. Well, if we took off this negative 10, it would be balanced because they're both the same thing. But that negative 10 is still on there. There we go. One click that way. So, but we still have the negative 10 there. So you can see that what this does is it makes it to where you could never balance it because the two negative 4q's have the same value. But the negative 10 is on one side but not on the other. So no matter what you do, you could never balance it. And the best way to spot one of these situations, at least that I've always found for me personally, is to go ahead and just work it out to where I end up and I can see if I can come up with a false statement of two numbers that don't equal one another. If that's the case, then there is no solution. On the next one here, well, this seems kind of interesting. I have negative 10s and positive 10s and negative 10s. Well, if I have 0 equals and I have positive 10s, let's look at this as plus and negative, right? Plus a negative 10s. Because if we learned anything in this course so far, it's where you can change the sign and take the opposite of the next number, right? Well, these are opposites, right? This and this, so they're going to cancel each other out. So we're going to end up with 0. Now, instead of like our last problem where we had 0 equals negative 10, a false statement, and there was no solution, now we see that we end up with a true statement. 0 indeed does equal 0. If you work it out to where you get rid of all the variables, all the terms with variables in them, and you end up with a statement of something equals itself, well, this is a situation to where there is an infinite number of solutions. All right, an infinite number of solutions. And the reason for that is, if we look back up at this problem here, no matter what we plug in for s, since these are opposites, if we plug in 5, we get 50, and over here we get negative 50. If we plug in 16, we get 160, and over here we get negative 160. So no matter what we plug in there, these are going to cancel each other out. They're going to equal 0, and we're always going to end up with 0 equals 0. So if you come up with if you go ahead and work it out, get rid of all the terms with the variables in them, and you end up with a statement of some number equals itself, in this situation, there are infinite number of solutions. So let's look and see what we have here. Well, this one here I probably won't have to work out, right? I got 13g and 13g. They're both positive. So these are the same value, right? That means that on the scale that we have here, I end up with a negative 16 and a negative 10. Negative 16, negative 10 are not equal to one another. Therefore, you could never balance this out. So therefore, there's no solution. If you were to go ahead and work this out, you would see that you would end up with, you'd subtract 13g from each side, and you'd end up with negative 10 equals negative 16. This is not a true statement, so therefore there is no solution. On the next one, looks like we might need to, let's go ahead and do a rewrite, and we're going to have to combine some like terms. So we have negative 4 minus 13. Let's make that negative 4 plus a negative 13. And then we have our negative 3k. Everything else is good to go there. I think I see what's going to happen here. Check this out. Negative 4, negative 13 equals negative 17, right? And negative 17, and let's change this to plus a negative 3k. So plus negative 3k, and set that equal to negative 17. Let's change this to plus a negative 3k. Plus negative 3k. I now have negative 17 plus negative 3k equals negative 17 plus negative 3k. Well, just like whenever I said if we can get down to a statement where we got 0 equals 0 or 7 equals 7 or whatever, if we have something that equals itself, then there's an infinite number of solutions. And as you can see, even before we go through any process of eliminating terms with variables in them, at this point, this and this are exactly the same. So since we have something equals itself, there is an infinite number of solutions. On the next one here, looks like we got some distributive property we have to do. And so let's go ahead and do that so we can see it a little more clearly. So let's distribute the 9 times 4. All right, and what is that, 36? 36 what? 36d. And then the 9 times 8 is indeed 72, correct? So plus 72. And we're going to subtract 14d and set that all equal to 20d. So don't forget the d, Mr. T. There we go. So we probably need to combine some like terms. We have terms of d here and terms of d here, 36 and 14. So we're going to take 36 and add to that this is minus 14, so it's plus negative 14. So we are adding a positive and a negative number, so we actually wish to subtract. So let's go ahead and find the difference there. That's 2 and that's 2. That sound right? 22 equals 22. The positive 36 has a greater absolute value than the negative 14. So since the 36 is positive, our answer of 22 remains positive. 22, and this is in terms of D, and that's positive. Good. So let's bring down our plus 72, and equals 20D. And I think we're going to end up with one solution here. Looking pretty good. So let's go ahead and add 20D to each side, or subtract. Take that back. So we're find the eraser there. Let's go ahead and subtract 20D from each side. minus 20D. Those will cancel each other out. And 22 minus 20 is 2. So we get 2D plus 72 equals 0. But we want this 72 over to the other side. Change the sign, which actually means we're subtracting 72, right? So we end up with 2D. At this point, I could say, oh, there's one solution because I see I'm going to end up there, right? But just for the fun of it, we'll go ahead and continue working on this. So I'll negative 72 on the right. And then let's divide everything by 2. And we end up with 2's canceling each other. And we have D on the left. And negative divided by positive is negative. It's 72 divided by 2. Well, let me see. 35 and 35 is 70. So it must be 36, right? Negative 36. So we see that D is equal to negative 36. It has one and only one answer because we came up with a variable equals some number. So we're good to go there. And going along, just peeking to see how many more we have. Negative divided by positive is negative, so negative 12J. And we are going to then do negative times negative. It's going to give me a positive, and I end up with, let's see, 3 times 16 should be 48, right? So equals negative 6J plus 18. So let's go ahead and, I think it's better if we add 12J, right? Because then we'll end up with a positive number of J's. So let's add 12J to each side. And that means that these are going to cancel each other out. And we're going to end up with our J's on the right. So let's go ahead and get that 18 over to the other side. Change the side, change the sign. So we're actually going to subtract 18. And those 18s will cancel each other out. So now we're going to end up with our constants on the left, variables on the right. So negative 6 plus 12 is a positive 6. So we have 6J on the right. And 48 minus 18 should be 30. I think I'm good to go there. And this is going to be what, one solution, right? Because we're going to divide by 6. Divide both sides by 6. The 6's cancel, leave me with J. 30 divided by 6 is 5, so J equals 5. So we have just one and only one solution on this, so we'll select one solution. I'm thinking, I think they're trying to trick us here. See that we see the 12 and we see the 4 and we see the 3, and we know that 4 times 3 is 12, and there's some type of there's a relationship between 4 and 3 and 12. So let's actually go ahead and take the steps before we get on it and say, oh, it looks like there's an infinite number of solutions. It's going to turn out to be the same thing. Let's go ahead and work that out. 4 times C is 4C. 4 times negative 3 is a negative 12. I'm going to set that equal to negative 12 and plus 4C. Well, indeed, it is the same thing, right? On one side of the scale, we got a positive 4C, and over here we have a positive 4C, and then here we'll circle the negative numbers, and I have negative 12. So if you were to picture this as a scale, we have the same thing on both sides. It's always going to remain balanced no matter what number you put in. So since we have something equals itself, it's an infinite number of solutions. Final question here, and that is looks like we need to do some distributive property, and it's looking kind of close. I'm guessing no solution. The 9s are going to cancel themselves. If you're saying 9s, what 9s? Check it out. Negative 3 times negative 3 is positive 9. 9 what? 9t. And already I'm saying, oh, I got a 9t on the other side. But I also have negative 3 times 18. Well, positive times negative is going to give me a negative. And I do have a negative 15 on the other side, but there's no way that 3 times 18 is negative 15. So I'm pretty much saying, okay, this is going to be a no solution situation, but we'll continue working it out and see. So 3 times negative 18 should be 30 and 18, 54, negative 54. I'm almost positive. Let's double check, make sure Mr. T hasn't lost his mind. Negative 3 times 18 is indeed negative 54. And we're going to set that equal to, so that was our distributive property. Let's set that equal to 9t minus 15. So let's see what happens. Let's subtract 9t from each side. Minus 9t, minus 9t, not 90, but 9t. And those cancel each other, and we leave us with negative 54 on the left. And those cancel each other, leaves us with negative 15. Does negative 54 equal negative 15? Indeed, it does not. So this is not a true statement. So, and the variables, the terms of variables just like disappeared. So we're left with two values that are not equal to one another, making a false statement. Therefore, we could never find a solution to this. So there's no solution. Remember, if you eliminate all of your terms with variables in them and end up with a statement that this number equals this number, and it's not a true statement, then there is no solution. You'll never find the answer. All right, so that includes all of my examples for IXL 8.W.15, where we find the number of solutions. Good luck with your activity.